So over here, we're starting with cosine, as you can see over here. And with cosine over here, we are getting some delta functions over here, which is why I said the delta was going to be somewhat important later on when we do a Fourier transformation of a cosine or sine. You figure out there's a delta in the, the frequency domain a few times. Now, as you can see, we use the same thing over here where we go to imaginary to do all the integrals, and you get to here. But one thing you need to realize as soon as you get here, this over here, this thing over here, is analogous. Each of those integrals are analogous to the rec function over here. When we do the rec function, it kind of is the same integral. If you look over here, it's just that this over here, omega, which is omega over here, omega plus once again, A was happening over here. But in the end of the day, it is the same function, basically. So you're going to get the same kind of sinc variety over here. With the sinc variety, if you graph it, you'll find that there's two bumps over here if you look at it. These bumps over here are from the shift over here. And as you make T stronger, this will go stronger, while everything else relatively doesn't show up. I mean, it does show up, but it'll cancel out with a negative and positive like this. And it's the integral, so they'll cancel out all of them. You can see over here there's an integral. Like if you take the integral of that, it would be negative plus, basically. Anyways, um, except for this big point over here. Anyways, with that said, we're gonna give you that this delta makes sense. This pi, on the other hand, you're gonna have to trust me that that works because to prove that pi, you need to know a little bit about dampening, and you need to put a little bit of a dampener over here, like a epsilon t, and then take that integral and then take a limit of it, which is way off the scope of everything. So I purposely did not choose to do that because then I would be just going insane with that. Anyway, next is sine h over here, which is just a basically exponents because this just getting rid of the imaginary, and you finally get this over here if you do all the integrals down. Now notice that there's a pattern here with the sine version of it. If you look at the sine version, it's just a plus difference. So there is a certain pattern to some of these Laplace domain stuff. You'll get to understand that there's a multiple patterns that you'll see as you do all of these things. Like this over here, you'll see that this is going to make a minus a no matter what. This one, no, not this one. It's this one. No, sorry. Exponents. I meant the exponent one. This one over here will get a minus a shift with the s. You'll see that later on. Anyways,